Welcome to the deep dive. Today, we're going to be looking at something I think every programmer needs to master,
Yeah,
and that is how to explain your thought process clearly.
right?
And we've got a fantastic blog post from Algo Academy that's packed with insights on just that.
Yeah.
Nailing these technical explanations is key for so much.
Oh, yeah.
Landing that senior role, getting buy-in on your projects,
Definitely.
even just mentoring a teammate.
Absolutely.
So by the end of this deep dive,
Yeah.
you're going to have the tools to make your ideas shine.
What I find so fascinating about this is that clear communication, it isn't just about helping others understand you.
Right.
It actually makes you a better programmer.
Oh, interesting.
When you're forced to articulate your process, you often spot holes in your logic
Oh, yeah.
or places where your solution could be more elegant.
It's like that saying,
Yeah.
you can't explain it simply, you don't understand it well enough.
Exactly. And when it comes to programming, that understanding translates into cleaner, more efficient code.
I like that.
Yeah.
So the Algo Academy post dives into this
Yes.
by saying you should start with like a high-level overview to set the stage.
Yes.
Before getting into the nitty-gritty details.
Yeah.
It's about giving your audience like a roadmap
Absolutely.
of your thought process.
Think of it this way. You're presenting a complex algorithm.
Right.
If you jump straight into the weeds, your audience is going to be lost.
Lost in the weeds, yeah.
But if you start by outlining the problem,
Right.
the core logic of your solution,
Okay.
and the key data structures,
Right.
you give them a framework to understand everything that follows.
So it's like,
Yeah,
here's the problem, here's how we're tackling it, and here are the main tools we'll use.
exactly. And don't forget to be upfront about any assumptions you're making.
Yeah.
Transparency is key to building trust and ensuring everyone's on the same page.
Now, even with a clear overview, explaining a really complex idea can still feel kind of overwhelming.
Right.
So what are some strategies for breaking things down so they're easier to digest?
One approach is to think like you're writing pseudocode.
Okay.
Break the problem down into smaller steps,
Right.
each representing a discrete action or a logical operation.
Yeah.
This helps your audience follow the flow of your thinking without getting bogged down in the syntax.
I like that. Pseudocode as a communication tool,
Yes,
not just for planning your code.
precisely.
Right.
And don't underestimate the power of grouping related concepts.
Yeah, that's good.
If you're explaining a recursive function, for example,
Okay.
first lay out the base case, then the recursive
Yeah.
step.
Yeah.
By presenting information in logical chunks, you make it easier for your audience to connect the dots.
You know what else helps people get it?
What's that?
Visuals.
Oh, absolutely.
A well-crafted diagram
Yes.
can often do way more than paragraphs of text.
Absolutely. Humans are visual creatures.
Right.
A flow chart, a state diagram, even a simple sketch on a whiteboard
Okay.
can make a complex process
Yeah.
instantly understandable.
Yeah, I like that.
The key is to keep your visuals clean and focused.
So no dumping your entire code base onto a slide,
Exactly.
no matter how colorful you make it.
Each visual element should serve a specific purpose and add clarity to your explanation.
Okay, so we've got overviews,
Yes.
we've got pseudocode thinking and visuals.
Yep.
What about when you're dealing with a concept that's just really hard to grasp?
Oh, yeah.
I'm thinking of things like recursion or dynamic programming,
Yeah.
stuff that can make even seasoned programmers scratch their heads.
This is where analogies become incredibly powerful.
Okay.
They bridge the gap between abstract concepts and something your audience can relate to.
Yeah.
It's like explaining recursion as a set of Russian nesting dolls.
I like that.
Each doll contains a smaller version of itself,
Right.
just like each recursive call contains a smaller version of the problem.
I love that analogy. It suddenly makes recursion feel a lot less intimidating.
The key is to choose analogies that resonate with your audience and accurately reflect the core principles of the concept you're explaining.
The Algo Academy post also talks about the importance of examples
Right.
and not just the happy path scenarios.
Oh, yeah.
You need to show how you'd handle those tricky edge cases too, right?
Absolutely. Walking through edge cases demonstrates a deep understanding of the problem and a commitment to robustness.
Okay.
Think of it like testing your code.
Right.
You don't just want to make sure it works in ideal conditions. You need to ensure it can handle unexpected inputs gracefully.
So it's not enough to say, oh yeah, my solution handles edge cases. You need to actually show how it does that.
Exactly. Provide specific examples of edge cases and demonstrate the logic your solution uses to address them.
Okay.
This not only proves your point, but also gives your audience a glimpse into your problem-solving process.
All right, so we've got overviews,
Yeah,
pseudocode thinking,
right.
visuals,
Uh-huh.
analogies,
Yeah,
and examples, including those edge cases.
exact.
Feeling a bit more confident in explaining your code already.
I think we've covered a lot of ground, but there's still more to explore.
I'm ready for more.
Up next, we'll dive into techniques like the Feynman technique
Ooh, that sounds interesting.
and using version control analogies to explain your thought process.
Okay.
And we'll tackle the often dreaded but absolutely essential task of documenting your code in a way that actually makes sense.
Looking forward to it.
Stay with us.
We'll be right back after a short break.
Welcome back to our deep dive into communicating your thought process.
Yeah.
Last time we talked about strategies like using visuals and analogies to make those complex concepts really click.
Right.
Now let's get even more specific
Okay.
with some techniques that can really level up your explanation game.
I'm all ears. Get me with those pro tips.
One technique that might surprise you is borrowing concepts from version control.
Version control. Okay.
Things like commits, branches, and merges.
Right.
These can be surprisingly helpful for explaining code changes or how you iterated on a solution.
Okay. I'm intrigued.
Yeah.
How would you actually use a version control analogy?
Imagine you're explaining how you optimized a piece of code.
Right.
You could frame it as a series of commits,
Okay.
each representing a stage in the optimization process.
I see.
Your initial, maybe less efficient approach would be like the first commit.
So each improvement would be like a new commit, building on the previous version.
Exactly. If you explored different approaches, those would be like branches,
Right.
with the best solution eventually being merged into the main code base.
Yep.
And the diffs between commits would highlight the specific changes you made along the way.
That's a really cool way to visualize the evolution of a solution. It's like giving your audience a behind-the-scenes look at your development process.
It is, and it can be especially helpful when explaining complex refactoring or optimization efforts where there were multiple iterations and decisions involved.
Now, the Algo Academy post also mentioned something called the Feynman technique.
Oh, yes.
What's that all about?
The Feynman technique is a fantastic method for testing your own understanding and simplifying complex ideas.
Okay.
It's named after the physicist Richard Feynman, who is known for his ability to explain difficult concepts in a clear and engaging way.
So it's not just about communicating with others, it's about clarifying your own thinking.
Exactly. The idea is to explain a concept as if you were teaching it to someone with no prior knowledge,
Okay.
like a child or someone completely outside your field.
So like explaining binary search to your grandma.
Exactly. By forcing yourself to simplify things, you often uncover gaps in your own understanding.
Yeah, that makes sense.
If you can't explain it simply, you probably don't understand it well enough yourself.
That makes a lot of sense.
Yeah.
So how do you actually use the Feynman technique?
There are 4 key steps.
Okay.
First, choose the concept you want to explain.
Got it.
Second, write it down or explain it out loud as if you're teaching it to a beginner.
Right.
Third, identify any areas where you struggle to simplify or where your explanation feels incomplete. And finally, revisit those tricky parts, do more research if needed, and try to refine your explanation until it's crystal clear.
I love how this technique not only helps you communicate more effectively, but also forces you to become a better learner.
It is.
It's a win-win.
Absolutely. Now let's shift gears and talk about something that's essential for every programmer.
Okay, what's that?
Documenting your code.
Ah, yes, the often dreaded code documentation.
I know, right?
But I have to admit, the Algo Academy post made a great point about focusing on the why behind your code, not just the what.
That's so important. Clear, concise comments that explain the reasoning behind your code are invaluable,
Right.
not only for others who might work on your project, but also for your future self.
Oh, for sure.
We've all been there. You revisit some code you wrote months ago and can't for the life of you remember why you did something a certain way.
It's like looking at an ancient artifact and wondering, what were they thinking?
Exactly.
Good code documentation helps you decipher those mysteries.
Exactly. So how do you make sure your code documentation is actually helpful?
Well, the article stressed explaining the why behind complex logic or unconventional approaches.
Yeah.
Sometimes the most obvious solution isn't the best one,
Right.
and it's crucial to explain those decisions.
Right, because your code might make perfect sense to you now,
Yeah.
but without proper documentation, it might be completely baffling to someone else or even to you a few months down the road.
It's true.
Another key point is using meaningful variable and function names.
Right.
This goes a long way in making your code more readable and self-documenting.
It's like writing a story.
Oh, yeah.
Clear, descriptive names help the reader follow the plot and understand the characters.
Right.
No one wants to read a story full of character A and character B.
I love that analogy. And just like a good story needs an introduction,
Yeah.
your code should too.
Okay.
Include a high-level description of the overall algorithm or approach at the beginning of each function or class.
Oh.
This provides context for anyone diving into that section of code.
So instead of just jumping into the technical details, you're setting the stage and telling them what to expect.
Exactly.
Kind of like a movie trailer.
And don't forget to document any assumptions, constraints, or edge cases that your code handles.
Right.
This helps prevent surprises and ensures that the code behaves as expected in different scenarios.
It's like adding those warning. Contents may be hot labels.
Exactly.
You're letting people know what they're getting into.
And lastly, use those studio comments liberally.
Yeah, those are good.
They're great for marking areas for future improvement or optimization,
Right.
leaving yourself reminders, and generally keeping your code base organized.
It's like having a built-in to-do list for your code.
Exactly.
Refactor this later, add more tests here, that kind of thing.
Exactly. Studio comments can be a lifesaver when you're working on large, complex projects.
All right, we've talked about documenting our code,
Right.
but the Algo Academy post emphasized one final and perhaps most important piece of advice, reflecting on our problem-solving process.
This is where the real learning and growth happen.
Okay.
By taking the time to analyze how you arrived at a solution.
Right.
You can identify patterns, refine your approach, and continuously improve your problem-solving skills.
It's like looking back at a race you just ran,
Oh, yeah.
analyzing your pace, your strategy, and what you could have done differently. Each race, or in this case, each problem you solve, becomes a learning experience.
Exactly. When you reflect on your problem-solving process, you're essentially asking yourself, how did I get here? What worked well? What could have been better?
So it's not just about finding the solution, it's about understanding the journey.
Precisely. And this reflection can lead to valuable insights.
Yeah.
You might realize that you tend to overcomplicate things.
Right.
Or that you jump into coding too quickly without fully understanding the problem.
Or maybe you discover a new technique that you can add to your problem-solving toolbox.
Absolutely. So how can we actually make time for this reflection? It's easy to get caught up in the rush of deadlines and just move on to the next problem.
One simple strategy is to just jot down your thoughts after solving a particularly challenging problem.
Oh, that's good.
What was your initial approach? What obstacles did you encounter? How did you overcome them?
It's like keeping a problem-solving journal.
Yeah.
You can track your progress over time, identify patterns in your thinking, and celebrate your growth as a programmer.
I love that idea. And, this journal could also be a great resource for brainstorming improvements to solutions you've already implemented.
Oh, that's a great point.
It's like a continuous feedback loop for your problem-solving skills.
That's a great point. By documenting your thought process and reflecting on your experiences, you create a valuable repository of knowledge that you can draw upon in the future.
Okay, we've covered a ton of ground in this part of our deep dive.
We have.
From version control analogies and the Feynman technique to the art of documenting your code and reflecting on your process.
And in the final part of this deep dive, we'll tie everything together and leave you with some key takeaways and actionable advice for becoming a clear and effective communicator.
I'm ready.
Stay tuned.
Welcome back to the deep dive. We've been exploring how to explain your thought process clearly as a programmer,
Yeah,
drawing some fantastic insights from that Algo Academy blog post.
it's been great.
We've covered a lot of ground, from starting with a clear overview
Right?
to breaking down those complex ideas.
Yeah.
Using visuals, analogies, and even borrowing those concepts from version control.
It's amazing how many tools we have at our disposal to make our thinking more transparent and accessible.
Right.
And, as we wrap up this deep dive,
Yeah.
one key takeaway that stands out for me is that clear communication.
Yeah.
It isn't just about making things easier for others. It's about becoming a better programmer yourself.
It's like that moment when you're explaining something
Yeah.
and you suddenly realize, wait, that doesn't quite make sense.
Yeah.
Or there's a more elegant way to do this.
Exactly.
The act of explaining forces you to refine your own thinking.
Exactly. It's like holding a mirror up to your own thought process.
I like that.
And when you see those areas for improvement,
Yeah.
you can go back and refine your code, your documentation, even your overall approach to problem solving.
So clear communication isn't just a soft skill.
No.
It's a fundamental part of being a great programmer.
Absolutely. And remember, it's not just about what you say,
Right.
it's about how you say it.
Oh, yeah. For sure.
We talked about tailoring your approach to your audience.
Right.
You wouldn't explain a complex algorithm the same way to a
Yeah.
fellow senior engineer
Yeah.
as you would to a junior developer or a non-technical stakeholder.
That's where those analogies and examples come in handy.
Exactly.
You need to find ways to connect with your audience,
Yeah.
to speak their language,
Yeah.
and to meet them where they are in terms of their technical understanding.
And don't underestimate the power of active listening.
Oh, yeah. That's so important.
Even the most brilliant explanation can fall flat if you're not paying attention to your audience's cues.
Good.
Are they following along? Do they have questions? Are they engaged?
It's like being a stand-up comedian.
Okay.
You need to read the room
Yeah.
and adjust your material based on how the audience is responding.
I love that analogy. And speaking of comedy,
Yeah,
don't be afraid to inject a little humor into your explanations.
that's good.
Programming can be a serious business,
Yeah.
but a well-placed joke or a lighthearted anecdote can make even the most technical topic more engaging.
It's about finding that balance between being informative and entertaining.
Exactly.
No one wants to listen to a dry, monotone lecture,
Yeah.
no matter how brilliant the content.
Absolutely. And remember, the journey to becoming a clear and effective communicator,
Right.
it's ongoing.
It is.
It's a skill you hone over time through practice, reflection, and a willingness to learn from your mistakes.
So to all you programmers out there,
Yeah.
embrace the challenge of explaining your thought process clearly.
It's a good one.
It's not always easy,
Right.
but it's incredibly rewarding,
Yes. Very rewarding.
both for you and for your audience.
And who knows? You might even inspire the next generation of programmers with your ability to make complex concepts clear and engaging.
That's a great point.
I think so.
Well, thank you for joining us on this deep dive
It's been fun.
into the art of communicating your thought process.
Yes.
We hope you've gained some valuable insights that you can apply to your own work and interactions.
And if you're eager to dive deeper,
Yeah.
be sure to check out the Algo Academy blog for more great content on this and other fascinating topics.
That is a great vlog.
Until next time.
Happy coding.